Have you ever wondered why mountains are so tall? It all started before you and I even existed. At the birth of our planet, approximately 4.5 billion years ago, formed out of a mixture of dust and gas surrounding our young sun. It grew larger to constant collisions with more dust and gas. Eventually, even asteroids, including the gigantic impact that threw enough debris to form the moon that now orbits our beloved planet. But that's a little too ancient. Good day everyone, I'm Raf, one of your guides to exploring the wonders of the earth. We have never really questioned in our daily lives, but when we go outside and see a beautiful landscape or an eye-catching rock formation, doesn't that make you wonder how they came to be? Over the course of billion years, our planet's surface has undergone countless change, the moving of the tectonic plates, the drifting of the continents, winds and ice shape and reshape the Earth's surface. In this video, we have here the Innovate Space will cover a brief guide to the surface of our planet. So sit back, relax, and enjoy the show.
The vast oceans, tall mountains, and enormous continents. These are just some of the features that make up the world we live in. The Earth's surface makes up only a tiny fraction of our planet, which we call the crust. But do you know what lies beneath it? Hi there, I'm Regina. To get an idea of how much of the Earth is the crust, take a look at this apple. An apple has three notable layers. A thin hard skin on the outside, covering the thick layer of yellow flesh, and its core at its center. Like this apple, our planet is also made up of several layers: the crust, the mantle, and the core. Can you see how thin is the crust compared to the rest of the Earth's layers? The crust describes the outermost layer of our planet. It is about 40 kilometers deep and makes up about 1% of the total volume of the Earth. It is also where you can find all known life. That includes you and me, and every person who's ever lived. It is generally divided into older, thick continental crust and younger, denser oceanic crust. The crust, along with the uppermost layer of the mantle, is known as the lithosphere. Underneath the crust lies a semi-liquid upper mantle layer of the molten magma we call the asthenosphere, which plays a significant role in the movement of the tectonic plates. The mantle is mostly solid and can be divided into the upper mantle and lower mantle. And below the mantle lies the core at the center of our planet, which can also be divided into the liquid outer core and solid inner core. Both primarily consist of iron and nickel. Another fact about our planet's core is that the outer core is actually responsible for Earth's magnetic field. Because of the liquid properties of the Earth's outer core, it is in a state of constant and turbulent convection. These movements create a strong magnetic field that protects us from the harmful cosmic radiation of outer space.
Did you know that all of the continents we know today were once a single, gigantic supercontinent? The supercontinent is said to have existed 300 million years ago when it was given the name Pangaea, meaning all of the Earth. Hi, I'm Bud. And I'm here to tell you a very amazing story.
If you look closely at the map of the world, you might notice that some of the edges of the continents line up. An example being the coastlines of Africa and South America. Isn't that interesting, right? But if they used to fit together, then that means they must have somehow broke up.
They ask you how you are, and you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
The notion of moving continents all started with dermatologist Alfred Wegener. This guy right here. He also noticed that the continents appear to fit together almost perfectly like a jigsaw puzzle. This led to him introduce a new idea: continental drift. Now, the continents being a snug fit wasn't all that evident together. He also noticed that fossils of certain animals appear in several different continents that are separated by vast distances and oceans. It's not a relationship. Now, how did the same animals end up all over the world? For geologists, thought of land bridges that connected the continents, but have since eroded away, or else the animals may have swam. He also found remains of an ancient fern. No, not that fern. This fern that have been found in 5 different continents. Now, ferns definitely can swim, except for it just didn't make sense. During these expeditions, they noticed the same types of rocks, mountains that lined up continuously between continents. There was a convincing body of evidence elsewhere. Not that funny, you know. Sadly, back then, the proposed idea of the continental drift was rejected. And let's just say, ridiculous. Simply because back then, how could you prove that continents could move? People thought that there was no such force that could move these massive land masses. They're massive, let me get wrong, sorry. That was before 1929, when geologist Arthur Holmes hypothesized that thermal convection in the upper mantle could create enough of a current to move the crust on top. Not long after the death of Alfred Wegener in the mid-90s, geologists like Harry Hess began studying the ocean floor, and they found that it's widening and moving. Now, Alfred Wegener's hypothesis didn't so far-fetched. During their studies, they also discovered a strange magnetic pattern along the seafloor ridge. Recall that the Earth is surrounded by a magnetic field from the North Pole to the South Pole. Earth's magnetic field has flipped hundreds of times over the planet's history. Magnetic minerals deep in the Earth and hot magma have served this magnetic fingerprint, and as they cool and harden, geologists could analyze the rock's magnetic polarity or polarity on either side of the ridge, determining its alignment to trace its history. The farther from the ridge, the older the rock was, providing more evidence of continental drift. So, in other words, Alfred Wegener was like saying, "How you feel about that, people? I can prove continental drift theory." Well, Alfred Wegener never got to see the fate of his efforts and ideas, even though it was pretty successful. It paved the way for the discovery and study of plate tectonics, and is now widely accepted.
Huh? What's this?
Tired of school? Doing an all-nighter again? Another project? Release your pent-up stress here at the Apex Stress Room, where you can compress tension and cause sheer stress on these rocks. You break it, we'll clean it. Come in, break rocks, leave happy at the Apex School's only stress room.
By now, you've probably seen what the world looks like. There are these massive land masses separated by oceans that we call continents. And in these continents is where we live. It would be easy to think that the Earth has always looked like this and always will. However, in reality, this is just how the surface of the Earth currently looks because it is changing very slowly. Most of these changes happen in the lithosphere. Hello, I'm Brent. Throughout this video, you've heard the term plate tectonics get thrown around. But what are plate tectonics anyway? Earth's lithosphere consists of a number of massive, irregularly shaped slabs of rock we call tectonic plates, with our continents lying on top and moving around with them. You don't notice this, but each plate is actually moving all the time in different ways, but pretty slowly actually, just about 3 to 5 centimeters each year. But millions of years, that really adds up. Now, you should be familiar with the supercontinent Pangaea from Maurice earlier, and it is the most famous and most recent supercontinent that began to form 300 million years ago. Its formation and subsequent separation were actually results of the movement of tectonic plates. So we now know the basics. Let's dive a little deeper into how it all works. Within the Earth, there is tremendous heat and pressure, and this drives slow circular movements called convection currents within the mantle layer, which in turn cause the plates to move and meet each other at their boundaries, which are known as plate boundaries. There are three kinds of plate boundaries, depending on what kind of movement occurs between two interacting plates. For constructive or divergent plate boundaries, two plates move away from each other. This movement forms a gap between plates that allows magma from the asthenosphere to seep through and cool to form new geological features. Most divergent plate boundaries is actually occurring underwater and form underwater mountain ranges called mid-ocean ridges and contribute to the process of seafloor spreading. The creation of the new oceanic crust from the magma that oozes from the mantle and goes to fill the space between the plates. You can actually see a notable example from space, the Mid-Atlantic Ridge under the Atlantic Ocean, that's actually pushing the Eurasian plate and the American plate 2.5 centimeters farther apart each other. At a destructive or convergent plate boundary, two plates move toward each other. Depending on the type of plate, different events might occur. When two continental plates smash together and push upwards, this results in the creation of fold mountains and is how the Himalayan mountain range in Nepal was formed, home to the highest mountains. However, usually the heavier and denser oceanic plate will dive under the other plate in a process called subduction and create what is called a subduction zone, where the tectonic plate dives back down the mantle and push molten rock up and form hotspots where volcanoes may form and deep sea trenches. At conservative or transformed plate boundaries, two plates slide against each other, either in different directions or in the same directions at different speeds. In parts of the world where this type of boundary occurs, more than likely experiences earthquakes. An example of this is San Andreas Fault in California. Our planet is a dynamic and active planet. The tectonic plates are always on the move due to convection currents from within. Although plates are moving far too slow for us to notice, it is responsible for most of devastating natural disasters like volcano eruptions, powerful earthquakes, and tsunamis.
Over the course of past millennia, we humans have reshaped our planet to better fit our needs. We built cities all over the globe, excavated mountains, expanded our control to every continent. Heck, we can even control the weather. We as a species have conquered our planet. A lot of what we see in the world we live in has been shaped by people. But how long do you think it will last? Hey yo, I'm Maurice. Before we continue, you need to remember that our planet is made out of several spheres, including the hydrosphere, biosphere, atmosphere, and geosphere. The geosphere includes all the rocks, land, and minerals making up the world we would describe as the solid part of the Earth. From the previous lesson, it should be highly apparent to you that now, the landforms we stand on are always changing. The geosphere is what's changing. Besides humans who have changed the Earth's geosphere through different activities such as mining and agriculture, processes like weathering, erosion, deposition have been chipping away at the surface of our planet, reshaping the lands. We also have a process responsible for the creation of new land, like islands and earthquakes, the formation of minerals and energy resources we use today, from magnetism, volcanism, and metamorphism. We have categorized these as exogenic or endogenic processes. The processes responsible for the ever-changing nature of our planet. Exogenic processes refers to the geological phenomena or the processes that occur externally on the surface of our planet. They are genetically hardwired to the hydrosphere, atmosphere, and the biosphere, which we humans are also a part of. Now let's go over the three notable examples of exogenic forces. Weathering is when the surface or subsurface rocks are broken down, dissolved, or disintegrate. This occurs through physical processes of breaking rocks, such as changing temperature, like freezing it, causing it to crack, forces like water and wind pushing against it, or through chemical processes, such as when the rock is exposed to oxygen, causing it to oxidize and rust. Erosion is a process by which natural forces move weathered rock and soil from one place to another.
Water is a major agent of erosion. Rain, rivers, floods, lakes, and the ocean carry away bits of soil and sand and slowly wash away the sediment. Winds also contribute to erosion by blowing the particles away, constantly transporting the dust, sand, and ash from one place to another. Even glaciers, they pick up pieces of the earth and drag them to new locations. And then we have gravity-related erosion, which is a major component of mass wasting events like avalanches or landslides. Endogenic forces are classified as either sudden movements, such as when an earthquake occurs, or slow movements, where usually it takes a span of multiple generations to longer time spans. More than 80% of the Earth's surface above and below sea level is of volcanic origin. Volcanic eruptions have produced mountains, plateaus, and plains, which subsequently eroded and weathered away into majestic landscapes and formed fertile soils. Magmatism, perhaps the single most critical ingredient in molding and understanding the planetary evolution. Simply put, magmatism is the formation of magma. Magma, as you may know it, is found beneath the surface of the Earth. It plays a key role in mountain formation as new ascending magma hardens at the surface of our planet and becomes new land on the surface of the planet. Volcanism is a process which molten rock from the Earth's interior erupts into the surface. When magma comes to the surface of the Earth, as it does during a volcanic eruption, it's called lava. Volcanism most commonly occurs at the boundaries of enormous rigid tectonic plates that make up the lithosphere. A great example of this would be the Pacific Ring of Fire, where 75% of volcanoes are situated. Movements of molten rock in the mantle caused by thermal convection currents coupled with gravitational effects of the changes of the Earth's surface. Now, when hot molten rocks reach the Earth's surface, they undergo changes in temperature and pressure, causing them to cool, solidify, and crystallize. Igneous rocks are formed through the process of solidification and crystallization of molten rocks, magma, and lava. Basalt, rhyolite, or obsidian are such examples of igneous rocks. This leads to metamorphism, when rocks are subjected to deep burial tectonic forces such as folding and high pressures and temperatures. The textures and minerals composition begin to change. Metamorphism is a solid-state transformation of rocks, where no melting occurs, and turn into rock with some chemistry but different textures and minerals. Protoliths are what we call the existing rock before they undergo these changes. These exogenic forces and endogenic forces have been around for a really long time and will continue to be around for as long as the planet still exists. When humanity is gone, these forces will chip away at our monuments and reclaim the planet for itself. Now, I brushed over the endogenic and exogenic forces that cause our planet to undergo constant change. Let's do the final topic we're covering in this video. Raph, take it away.
Thanks, Juan. Now, quick question. What is the difference between rocks and mineral? Now, in straightforward terms, mineral are naturally occurring substance represented by a chemical formula that is usually solid and inorganic and has crystal structure. Elements like copper, iron, and gold are examples of minerals. While rocks are composed of one and more minerals and do not have crystal structure nor have different chemical formula. Sometimes a rock may have certain organics remain in it. Rocks also exhibit some physical properties like color, shape, luster, texture, and pattern. Some examples of rocks involve limestone, granite, marble, and sandstone. Each of these rocks consists of different minerals that have been mixed up with the rocks through different geologic processes. Rocks and minerals are some of the most fascinating and valuable resources known to man. Rocks and minerals make up with the earth around us and known to be the building blocks of our active planet. Rocks and minerals form the earth since humanity first learned to make tools and are what we use to build our cities, infrastructure, and society.
Thank you all for staying with us till the end.
In this video, we hope that you learned a thing or two about the surface of the planet we live on.
If you like this video, don't hesitate to click that thumbs up button.
And of course, if you don't want to miss our next video, go hit the subscribe button.
It's free and doesn't take much time.
Once again, thank you for watching our video. We all worked so hard on it and our editor was high. Once again, this has been
Innovation.